Good morning to one and all present here. With immense joy, I welcome you all for session 10 of day 6 in our MPP program. A day that makes continuity in learning, yet brings a new spark of ideas, perspectives, and wisdom. Each day of this faculty development program has been a journey of learning, sharing, and growing together, and today is no exception. We are all set to begin another enlightening session that promises to inspire and empower us. We are honored to welcome our distinguished chief guest, Dr. P. Namalwar, Associate Professor in the Department of Electrical and Electronics Engineering at Builders Engineering College with over 21 years of rich experience across both polytechnic and engineering institutions. Dr. Namalwar has dedicated his career to advancing knowledge in electrical engineering. He holds a PhD in electrical engineering from Anna University, Chennai, along with the multiple degrees in power electronics and electrical engineering, consistently achieving distinction throughout his academic journey. He is not only an accomplished teacher but also a prolific researcher. He has published over 19 international journal papers, presented international conferences, and holds a patent on innovative methods for prevention and recurrence of cancer through food theory. His research expertise spans power electronics, renewable energy system, solar PV integration, and grid technologies, with several of his works indexed in Scopus, WAS, and SCIE journals. Beyond his academic research contribution, he has played a vital role in academic leadership and quality assurance, having served as an NPA and NAC coordinator, academic coordinator, and even as a head of the department at the AIPT College of Engineering. He is a lifetime member of ISTE and an active member of IAENG, further extending his contribution as a reviewer for the reputed international journals. With this note, I welcome our chief guest to take over the session. Welcome, sir.
Correct.
Morning, Gurudas here. I thank the management to take up this chance and all contributed for this. Myself, Dr. P. Namalwar, presently working as Associate Professor in the Department of Electricity. Earlier it was Builders Engineering College. Now the college name has been renamed as Congayam Institute of Technology, which is located in the area of Tirupur. This is global energy generation scenario. Here I have shown some selected countries only. You can able to see that the last one is India. We are utilizing only the slide shows the global energy generation scenario. Here I have shown only 4 selected countries: USA, Japan, China, and India. In this, how we are utilizing the renewable energy sources. That is only 50% only we are using the renewable energy resources. Okay, this slide depicts that energy depletion curve. You can able to observe that the first one is coal, which will deplete in 200 years. That means we will lose that coal in 200 years, and for oil, it will deplete in 100 years, and also for gas, it will deplete in 150 years, and for last one, uranium, we will lose that one uranium in 50 years. My title is, you can able to see that my title is utilizing power electronics in renewable energy. To relate that one, we are going to see how renewable power electronics can be used in renewable energy sources. UNIPCC, United Nations Intergovernmental Panel on Climate Change, represents that 50% of total world energy can met by the renewable source by 2050 only. Okay, next, we are having different kinds of renewable energy sources like hydro, wind, solar, biofuel, geothermal, wave, and tidal powers are called green energy. Generally, we are calling this hydro, wind, or all green energies, and it is available in nature. Abundant of sources are available. Okay. Among these hydro, wind, solar, among these wind and solar resources, which are heavily, that is highly dependent of power electronics for conversion and control. Okay. Very particularly, that power fluctuation caused by the variability. That means your wind and solar will vary frequently based on the nature, climatic condition. The wind and solar radiation will vary frequently. For that, power electronic control is obvious, more efficient because of the switching mode power converters. We are using that power semiconductor devices in power electronics converters. What we can able to observe, without our electronic system, we can't able to convert that renewable energy sources effectively. That we can able to observe from this. Okay, this slide shows that advancement in power electronics technology. We can able to see that from first generation to that fourth generation. This first generation, it is started in the year of 1957. There we are utilized only thyristor alone, and in the second generation we utilized GTO and GTR, BJT, power MOSFET, thyristor. GTO and GTR both are comes under the term of thyristor. One is combination of, one is comes under the thyristor family, and another one is comes under the transistor family. BJT also BJT, one of the transistor family, power MOSFET and thyristor. This one is second generation, and in third generation we are using that IGBT and MOSFET. IGBT and MOSFET. From that IGBT and MOSFET, the fourth generation entered with high performance IGBT and MOSFET called wide band devices, band gap devices. That's called wide band gap devices. We will see that one in the next slide. The performance characteristics of that first to fourth generation characteristics: switching times, losses, power stress, cost, temperature stress. We will consider that one. On the right side, we have given that research area. In 1957 to 2000, the research areas are circuit topology. We are concentrated only on the circuit topologies and modeling control, gate driver, digital control. And in that, after that fourth generation, that is after 2000, we are concentrating on topology and control, gate driver circuit, packaging, and then thermal management, electromagnetic interference area, and modularization. That means we are modulation means we are dividing India one big ஒரு பெரிய ஏரியா இருக்கு அதை டிவைட் பண்ணி because that is called modularization. Okay. Along with this, that is from first generation to fourth generation, along with the development of power electronics technology, renewable energy sources, power semiconductor devices also developing. Okay, now we discussed about that fourth generation wide bandgap devices that we will discuss now. Advanced power electronics that called wide bandgap material. That means silicon carbide and gallium nitride. Semiconductors offers numerous advantages over traditional silicon semiconductors. Okay. In that, mainly silicon carbide based devices. Here, can operate at higher efficiency. Everything is in high level. Efficiency higher, voltage higher. We can use it for high voltages and switching frequencies also higher in silicon carbide based devices. So SiC based photovoltaic inverter can operate at 90% efficiency. This is the maximum efficiency we can obtain by using this SiC. Gallium nitride based devices, somewhat different from that SiC, that can operate at high frequency and also in low voltages, operate at lower temperatures than SiC. When compared to the SiC, the characteristics is somewhat lower than that of SiC. It can operate at a high frequency also. That is gallium nitride enables small passive. It is used for enabling that smaller passive components such as inductor, capacitors, like that. This is the main topic. That is power converters. We are having main 4 power converters for converting the renewable energy sources. Here I have given that DC to DC converter called chopper, and then DC to AC converter called inverter, and then AC to this one you know already, and then AC to DC converter is called as rectifier, and then AC to AC called as cycloconverter or matrix converter. Here power electronics is a silent force behind that renewable revolution. Okay, without knowing that, அதாவது சைலண்டா பேக்ரவுண்ட்ல இருந்து எந்த விதமான அவுட்புட்டையும் தெரியாமலே ஒர்க் பண்ணிட்டு இருக்கிறது that power electronics converters. First we will see that DC to DC converter. DC to DC converter, that we know that chopper, we will call that chopper, also called as voltage manager. Okay, it is mainly used for converting that solar energy into effectively to convert that solar energy. We are using that DC to DC converter, and also in battery energy management system, with battery energy storage. So first solar, we will see that solar PV. It is used to maximizing that means it is used to harvest or maximizing the output power. We are using this DC to DC converter in SPV system. And then here I have showcased that maximum what is power point tracking. We'll see that here the power output from the PV array is a variable one that you know very well. Based on the irradiance value, that is solar insolation value, it will frequently vary. That will be regulated by the DC to DC converter. After here, you will get only variable output. Here we can able to get constant DC output. To get this one, we need conventional one, but also we can use this MPPT based control. This one is maximum power point tracking system. Here that x-axis shows the voltage, and on the right side power, on the left side current. I will show an animation in that next slide. Always, for example, we must operate this VA characteristics at maximum level. Okay, first we will see that what is MPPT and what are the benefits of that one. Here in that first point, we said technique used to generate, that means used to extract or harvest the solar power effectively. Next, to detect the real-time generator voltage of solar panel and to track the maximum power and current. In theoretically speaking, that compared to the conventional solar controller, theoretically speaking, we can able to get 50% more output when compared to the conventional converter. Actually, practically, the ultimate MPPT efficiency can be increased 20 to 30% only practically possible. And then for that extraction, we are using some algorithms to maximize the performance of the solar PV system. Here we are using some algorithms. Okay, what is the purpose of that algorithm? It is used to track the solar installation value effectively. Okay, control algorithm should keep the testing. It will keep on tracking the solar radiation value. For that, we are using this control algorithm. Second part, it is used to force the system to track the MPPT. And then the third point, based on the third point, control algorithm forces the PV array to operate at maximum MPP by changing the voltage, that is terminal voltage. For that, familiar algorithms are incremental conductance algorithm, perturb and observe, constant reference voltage system. One more thing, numerous meta-heuristic algorithms are available in the research or available in nowadays. Okay, numerous meta-heuristic. What is the meaning of the meta-heuristic? Means bio-inspired algorithm. Bio-inspired means natural behavior based. There are lots of natural behavior algorithms are available. Lots of maximum, lots of natural behavior, that is called a meta-heuristic algorithm. Lots of algorithms are available in the research. This one is conventional DC to AC. That means we are converting, first one we discussed DC to DC, this one is second DC to AC. Here we are converting that solar power straight away into connected into the grid. For that we are using inverter. It should have some qualities. It should always follow the MPPT and the DC current voltage, and then it should follow the monitoring parameters. Actually, here the power, active power starts to flow from panel to converter, but reactive power is bidirectional one. And then power, active power will be unidirectional. Reactive power is a bidirectional one. And then inverters for grid integration. Here, sir, I forgot to say one thing. Here, various algorithms are available. Perturb and observe, incremental conductance, constant reference voltage. What's the purpose of this MPPT? That we will see here. Here we discuss the points for what is the importance of MPP. That means maximum power point tracker importance பார்த்தோம். Here we will see the animation video. It is not animation video. It is a real video which we have taken. It is practically taken video. Here you can able to see the MPPT, how the MPPT works. If any obstacles appear on the solar panel, the output get reduced, and also the MPPT on that panel doesn't reach that MPPT. Okay, now shadow is appeared on the panel, so the output is minimum. You can able to see that if the shadow is starts to remove, then the output starts to increase. Finally, it reaches the maximum power point. This blue color shows the current value and red color shows the power value. X-axis voltage value. When the shadow is removed, it starts to produce the maximum output. So finally, what we the several algorithms called incremental conductance and constant reference voltage for current algorithms are used to track the maximum power point. Okay, this one called the DC to AC converter, also called as inverter. Usually it is available on the back side of the panel nowadays, called micro inverter. In addition to that, we can able to in three-phase converters. There is in addition to that VSI and CSI. VSI means voltage source inverter and CSI means current source inverter. Multi-level converters are plays vital role nowadays. Okay, why it is called MLI? We are getting the output in multi-stage, so it is called as MLI. Advantages of MLI are it splits the output voltage into multi-level. That is, it is not in the waveform sinusoidal. It is not in the sharp sinusoidal, but it behaves the pattern of sinusoidal. Okay, reduces the losses and increasing the energy efficiency. Okay, and then also it improves the quality. Always while integrating into the grid, we need the quality of the power. So it reduces the harmonics level, harmonic content, and the current and voltage. And also, if it is not the harmonic content and the current harmonics are not present, means then automatically automatically it will minimize the power transformer losses. Okay, this is one is the schematic diagram of the grid type SPV system. This one is single stage. Here, grid power connector converter only used. Grid power converter means straight away it converts the solar energy into grid. Okay, this slide shows the two stage. That means first stage converts the DC to DC conversion, and then the second stage convert that voltage into DC voltage into AC voltage. Okay, this one is two stage. Previously we see that single stage. What's the difference between it has only one converter? It converts the solar power straight away into AC, and it is connected to the grid. This one is two stage system. This is also grid type SPV system. First stage converts the variable DC into steady state DC, and that steady state DC converts into AC by using BSI. For controlling, we are using lots of methods. From DC to DC side, we are using it is a traditional one, but also, and on the right side, any type of converter control can be used. This one is a complete control structure for grid type SPV system. This one is two-stage system. That one is first stage. This one is PV array. Here we have converted that PV array voltage given into the DC to DC converter, and then that one is converted into AC by using this inverter. After that, grid tie transformer is connected to the grid tie transformer, and it is connected to the grid. Okay. For that, we have different major three controls. That one is basic control, and then PV system specific control, and then advanced feature control. What are the basic control? Here we should have basic control called voltage for current control, and it should synchronize with the grid. Before integrating into generated power, we must follow some rules. It must be before synchronization. And then it has one further specific control called APPD, anti-aliasing. What is the meaning of anti-aliasing? Means disconnection of generated power from the grid, and it should have some power quality. That means voltage power quality. It should have voltage quality and current quality. It must be the range of TH, total harmonic distortion value, should be less than that of 5%. And also there will be a seamless transition. That means power generation, power integration. That means power integration into the grid, extraction from the grid. Okay, advanced feature. Advanced feature means some additional advanced feature called monitoring. That means panel monitoring, solar cell panel monitoring. We are following the temperature of the PV conditions, and then emulsion. Initial emulsion means during initial startup, and then weather forecasting. Now the meteorological department. Meteorological department, we can get data throughout the year. Even to analyze the data, you can get meteorological data from the. If you mail to the meteorological department, you can be able to get that data. Even for doing your project also, for your final year project, you can do it. As a student, you can do it. You can get meteorological data from the meteorological department for day 1 to January 1 to December 31st. Up to that, you can get 365 days data. You can get it from the meteorological department, and you can analyze the data for PV and wind. That is also considered as project, final year project. Okay. Next, energy storage. If there is no load, we need to do? We need to store the energy. For that, we have a provision, black start, and then black start control. Black start control means without any. That means for starting the system, we need some power. Okay, for starting the system, we need some power for controlling this DC to DC converter. For controlling this DC to AC converter, we need some power. Without that voltage, we are starting means that is called a black start. Right through. That point, low voltage right through. That means right through capability curve is that. That means how long the voltage is reversed. What it indicates, instead of delivering power, it starts to absorb power. That means during partial shading condition, instead of generating power, module 3 alone starts to consume power. Okay? Okay. What are the effects? What will happen if we left the partial shading condition? அதாவது module 3 நம்ம அப்படியே விட்டுட்டோம்னா என்ன நடக்கும்? Shaded PV cells forced to work in the current higher than the generated current and will act as a load for the PV cells. That means instead of generating power, it starts to consume power. That module 3 alone. The terminal voltage across the shaded cells will become negative. Shaded cell instead of generating dissipates energy and heated up results browning. That means if you not consider that shading means what will happen? The surface will get browning, bubble formation will happen, hot spot will create, finally it will get damage. So we need to take care of that partial shading. Okay, that means the moon panel is the moon panel of one on the 100%, other unshaded module. Unshaded means 100% irradiation getting. This one is also 100% irradiation getting. The third panel of 50% shading இருக்கு. அல்லது bird debris உட்கார்ந்திருக்கு, bird debris இருக்கு, அல்லது ஏதோ ஒரு particle மேல இருக்குனாக்கா we should take care of that one. Okay, results on the if you are left that one, that surface will get damaged. Panel surface will get damaged. So we need to give importance for shading. Okay, this can be overcome by two ways. One is by we can use bypass diodes. We can use bypass diodes or we can use sting arrangement. This bypass diodes can be easily done, but the sting arrangement is a tedious one. We will see this bypass diode concept alone. Here I have taken 4 modules that all the 4 modules are connected in series. Initially, let us consider this module 1 getting 100% radiation from the solar, module 2 is getting 100% irradiation from the solar, and then this third module and fourth module is getting only 50% of solar radiation value. Okay, 4 modules are connected in series. Okay, module 1 getting 100%, it can able to generate 8.4 ampere. And then module 2 also getting 100% irradiation value, it can able to generate 8.4 ampere. But due to 50% solar radiation value, this module 3 and module 4 can able to generate only 4.2 ampere. Okay. Because of shading. If the load current is less than that of 4.2 ampere, then there is no harm for the panels. Because இதில் பார்த்தீங்கன்னா 100% radiation இருக்கு, so that it can generate 8.4 ampere. For this 50% shading நடக்குது, இதுலேயும் 50% shading இருக்கு. So if your load is 4.2 ampere only means there is no harm. எந்த ஒரு ப்ராப்ளமும் இருக்காது. Okay. If the load is greater than that of 4.2 ampere, instead of generating power, it starts to consume power. Module 3 and module 4, enagunaka, it starts to consume power. If it starts consume power, then a panel will get damaged. Okay. For that, we need to provide bypass diode. If the rating, that means current rating is greater, load நம்ம கொடுக்கிற லோடுக்கு பொறுத்து தான் இருக்கு. If the load is 4.2 greater than that 4.2 ampere means then that additional current starts to flow from up to this module 1 can generate 100%, module 2 100%, so it can pass through that one. If the rating is greater than that of 1 means then that additional current starts to flow through that bypass diodes. So here that power electronic device, here also power electronic device, all the diode is used for renewable energy recover. Okay, next wind power conversion system. Here it is a single stage wind power conversion system. that you know that generator here we are using, usually we are using induction generator. When the induction generator will start to generate voltage, when the speed is greater than that of synchronous speed, then it will start to act as a induction generator. One more way we can say that when the slip is negative, it can start to generate voltage. This one is single stage power conversion system. Next, this one is two-stage power conversion system. Here, that induction generator voltage, that is 3-phase voltage, is converted into DC by using rectifiers, and then the DC voltage is converted into AC and it is connected to the grid. This one is two-stage system. This one is wind power conversion system. Next one is three-stage system. Three-stage system means here we are using three stages. First stage is used to rectify that AC voltage into DC voltage, and that one is given to the chopper. The mid one is called the chopper. This can be used to stabilize the voltage. Why it is first stage, why the second stage, why third stage means we are using to stabilize. And one more thing, we need to, while connecting into the gate, we need to manage the frequency. For that reason, we are using the third stage. This one is called the doubly fed induction generator. Doubly fed induction generator is usually doubly fed. When the generator is slip ring type, then we need to go for doubly fed induction generator. This doubly fed induction generator with full control circuit is shown here. And then this one is doubly fed induction generator with the two-stage, that means partial scale power converter with the doubly fed induction generator, and then synchronous by second one is synchronous generator type. This one is complete control structure for grid tied inverter system as we discussed in solar PV. Like here also, this one may be a DFLG, doubly fed induction generator, or synchronous generator, or induction generator, any one. We need to convert that AC into DC. What is the reason for converting that AC into DC? We can connect that one into straight away to the grid. First we are converting that AC into DC. What is the purpose? We need to stabilize that. For that reason, we are converting that AC into DC. After that, the DC voltage is converted into AC by using that inverter. Before connecting it to the grid, we need to stabilize the voltage. Similar to that PV control, here also major 4 control what we discussed in the PV side. Here in this doubly fed induction generator, we need to concentrate one point. This one is connected to the grid. This rotor side 3 voltages are fed back to the grid. This one is called as slip power recovery system. Okay, what is the frequency of this one? Is F dash is equal to SF, that you know very well. Usually the rotor frequency will be in the range of 3 Hz or 2 Hz, that with the voltage of 110 or 230 or 440. But the frequency of the system is in the range of slip frequency. Slip frequency means it will be in the range of 2 Hz. That 2 Hz with the voltage is converted into related to the grid frequency. That means that can be converted by using front-end converter. This one gives the torque speed characteristics of wind turbine for different in velocities. As we discussed, similar to that for PV system, solar system, here also we are using torque speed characteristics for, that means x-axis turbine rotational speed, and then y-axis turbine torque for different velocities. Similar to that of solar, here we are using wind speed and active power control. That means here when the wind speed is less than that of this one, that means 5 meters per second, immediately that wind blades will stop rotating. And then if the wind speed is greater than that of 25 meters per second, then it is called cutout wind speed. Okay, திருப்பூர்ல இருந்துட்டு பழனி ரோட்ல பாத்தீங்கன்னாக்கா அந்த சைட்லலாம் வந்து நிறைய windmills இருக்கும். You can able to see lots of windmills there. We are arranging frequently from our campus. We are frequently arranging industry IB for students who are visiting this windmill. Even we can go inside that tower. Similar to that PV, here also we are using control algorithms in wind energy. Variables here what we can control? We can control that pitch and the speed of the wind turbine. For that, it is complex one and nonlinear system. Okay, it is one more difficult issue. That means it is not able to. Sometimes it is not able to solve this problem to exert the maximum power from the wind system. Advanced optimization techniques, that means complex algorithms are available for extracting or harvesting maximum power from the wind system. Next, research focus in renewable energy systems. First one is integration with the renewable energy system. Usually generated power integrating into grid is complex one. To integrate that one, the first point integrating grid with the renewable energy system. Second one is selection of suitable renewable energy storage technology. Renewable energy storage system is one of the research area, and then BMS battery management system and suitable converter for RES also one of the research area, and then islanding issue. Islanding means disconnection of inverter from the grid system, and that is also one of the focused area. Collection of renewable energy during partial shading condition. That is this point. Collection of power from the PV during partial shading condition. That is one area. And then grid, smart grids and microgrid grids. Optimization. That is also one of the research area. Building integrated SPV system. Usually most of them now buildings மேல solar system use பண்ணி they are collecting power for energies in the local loads. For that, they are using building integrated SPV system. Conclusion, here party can able to see that power electronics plays a vital role in converting that renewable energy source of wind and PV. Many power grids are designed. That means here what are the problems we are facing is that most of them are with the older technologies. It is a challenging one for integrating that new power electronic device based existing infrastructure. And then one more thing, collaboration between the semiconductor manufacturer and the power system designer. That is one problem. Evolution of power electronics defines the future of the renewable energy utilization. That means evolution. That means in the third slide we discussed about that evolution of power electronics. That one redefines the future of renewable energy utilization. And then one of the previous world powered entirely by renewable energy is getting closer, and it is closer to reality. For example, we will go to the first slide. Here, if we are started to utilize the renewable energy, then the curve will become infinity. Okay, if you are started to extract more power from the renewable energy sources, it will not deplete, it will not last. Then the curve becomes infinity. Okay, that's all. Before that, how many of you know that Jotilo software for referencing Jotilos? This one is referencing software. Referencing consists of citing sources in the text. That means usually when we are writing the paper, we are using a reference. Referencing means ஒருத்தர் ஒரு கான்செப்டை சொல்லியிருப்பாரு, அந்த கான்செப்டை நம்ம அப்படியே எடுத்து எழுதக்கூடாது. அப்படி எழுதணும்னா இட்ஸ் a mistake. For that reason, we need to cite that paper in your work. Okay. In text citation, that one is including that content partially. அவர் இப்படி சொல்லியிருக்காங்க கண்டென்ட்டை கொடுத்துட்டு next we need to cite that. That is the respect giving for that author. Then referencing styles are there. There are lots of referencing styles. One is that we familiar known one is identity, Harvard and Vancouver. And then next one, essential for giving credit. It's also credit to the persons. If you are mentioned that paper in your citation, it will give credit to that researchers or authors. And then there will be some format for giving that referencing. First one, author names, and then journal title, publication, year, volume, issue, page, and article number, TOI number, digital object identifier, or URL. These are all that must consist in the referencing. Okay. There are some softwares are used for referencing. Main softwares are EndNote, Mendeley, Jotiro, RefWorks. These are the softwares. Today we will see that how that Jotiro works. Here I have taken that Jotiro only. I am going to give introduction to how we can use that Jotiro software. This can be very much useful for those who are doing research work. What is the first step? Means first you need to install the Jotiro software from the Google. Sorry. Okay. Okay, no problem. First, you need to download that software from the Google. After downloading that, you close all the Microsoft Office which is in open condition. Jotiro install பண்ணிடுங்க. Jotiroவை Googleல it is available free download. Jotiro install பண்ணிடுங்க. Install பண்ணிட்டு and then close all the Microsoft Office which is in open condition. Even இப்போ PPT ஓபன்ல இருக்கு இல்லையா, இதையும் வந்து க்ளோஸ் பண்ண மைக்ரோசாஃப்ட் ஆஃபீஸ் ரிலேட்டட் டு எல்லாத்தையுமே you need to close பண்ணிட்டு and then start to install that one. Once installed, it will appear in that desktop icon. Once installed means it will appear like this. Okay. After opening this one, you can open a Word file. For Word file open பண்ணீங்கன்னா, even it is a new one, then there will be a separate you call Jotiro. Jotiroன்னு இங்க visible ஆக ஆரம்பிச்சோம். சரிங்களா? First step, you need to install the Jotiro. While installing Jotiro, the Microsoft Office எதுவும் ஓபன் ஆகக்கூடாது, ஓபன்ல இருக்கக்கூடாது. Even it is a PPT or MS Office, everything should be closed. Okay. After that, if you are opened that MS Office, then there will be a separate icon will appear here. Okay. After that one, open this Jotiro. You need to add the papers. ஓகே, ஃபர்ஸ்ட் ஜொட்டிலோ ஓப்பன் பண்ணிக்கோங்க. ஜொட்டிலோ ஓப்பன் பண்ணிங்கனாக்கா this ஐகான் வந்து இன்ஸ்டால் பண்ண உடனே இந்த ஐகான் வந்து அப்பியர் ஆக ஆரம்பிச்சிடும். அந்த ஐகான் ஓப்பன் பண்ணிட்டீங்கனாக்கா it will be look like this, எம்டியா இருக்கும். சரிங்களா? After that open a Word file. There will be one separate is called Jotilo அப்படின்னு இருக்கும். சரிங்களா? Second step over. Third one, if what paper you are going to insert அப்படின்றத முடிவு பண்ணிக்கோங்க. For example, I am going to insert one reference paper, any one paper. You can take it from any websites. Okay, I was opened the paper. Here I am having one paper called this. I am taking this one. I am open this paper. I want to give this paper in my reference. So I want to include this paper in my reference. An indirect matrix converter for dual output AC drive system with reduced number of power transistor. So on this right side, here there is one icon. Okay, here there is one icon. It will be automatically created in your browser. Okay, the browser la automatically create item. If you click that one, it will ask where you need to save. Enga save pannon kekkum. Just give enter. Enter கொடுத்துட்டு after that if you come to the Jotilo, that paper will be included here. அந்த paper வந்து இங்க include ஆயிடும். சரிங்களா? Once அந்த ஐகானை click பண்ணீங்கன்னா that paper will be included here. The complete detail of that paper will be available on the site, right side. அந்த Jotilo software complete dataவை எடுத்துக்கும். என்னென்ன டேட்டா இருக்கு பாருங்க. ஆத்தருடைய ஃபர்ஸ்ட் ஆத்தர் யாரு, செகண்ட் ஆத்தர் யாரு, தேர்ட் ஆத்தர் யாரு, அப்ஸ்ட்ராக்ட் என்ன, அந்த பேப்பர் எந்த இயர்ல பப்ளிஷ் ஆயிருக்கு, அண்ட் தென் அது I2B கான்ஃபரன்ஸ், பேஜ் நம்பர் என்ன, அதனுடைய DOI நம்பர் என்ன, அதனுடைய URL என்ன, எந்த இதுல வந்திருக்கு, எல்லா கம்ப்ளீட் டீடைல் இட் வில் டேக். ஓகே, ஸோ நெக்ஸ்ட் if you are having 20 papers for referencing means you need to include all the papers like this by going that website. அந்த வெப்சைட்டுக்கு போய் எல்லா பேப்பரையும் அந்த ஐகானை கிளிக் பண்ற வேண்டிய வேலை தான், அதுவே எடுத்து வந்து இங்க வச்சுக்கணும். சரிங்களா? all the 20 papers you can able to include like that. எல்லா பேப்பரையும் அந்த மாதிரி இன்க்ளூட் பண்ணிடுங்க. இன்க்ளூட் பண்ணிட்டு then if all the 20 papers are included, then you go to the your paper content. Let us I have taken this one is my content. இந்த பேப்பர் எடுத்துக்கிட்டா என்னுடைய பேப்பர் எடுத்தாச்சு. இந்த பேப்பர்ல I was included. Then sorry, this is the content of my paper. I want to include that citation here. அந்த பேப்பர் வந்து ஒரு சைட்டேஷனை இங்க கொண்டு வந்து கொடுக்க போறேன். அதுக்கு I am selecting this area. இந்த ஏரியாவை செலக்ட் பண்ணிட்டேன். That is continuous depletion place-ல I am place that cursor. Open this Jotilo, add citation, and then what the word you அங்கிருந்து ஏதோ ஒரு வேர்டை மட்டும் டைப் பண்ணுங்க. ஜஸ்ட் டைப் பண்ணுங்க. அந்த பேப்பர்ல இருக்கிற வேர்டு இன்டைரக்ட் மேட்ரிக்ஸ், அந்த மேட்ரிக்ஸ் டைப் பண்ணீங்கனாலே போதும். இந்த பிளேஸ்ல கர்சர் வச்சிட்டு add citation, indirect matrix னு இல்லையா, just you type that matrix, that paper will show here. Just click that one, give enter, and then once again give enter. That paper will be included here. Before that you need to go here, document preference. என்ன டைப்ல டாக்குமெண்ட் கொடுக்க போறீங்க, I2B ஃபார்மட்ல என்னன்னு கொடுத்து ஓகே கொடுத்துட்டீங்கன்னாக்கா place the cursor here, add citation, type that paper, include that paper, give enter. Then that paper is included here. Okay. Suppose I want to add one more paper in that same place. Give add citation. Go to that paper. What is the one more name in matrix? That add citation. Type that word and select that paper and give enter. Okay. And do something error. Suppose I want to add that paper here, so just click that one and add that paper matrix. So the second paper is added here. So paper 1, paper 2 added. Suppose you want to include a third paper in between this here. இந்த இடத்துல நீங்க ஆட் பண்ணணும். அப்படி ஆட் பண்ணீங்கன்னா for example if you are doing your research work, for example if you are writing thesis means you need to add 100 paper means 100ல paper add பண்ணிட்டு நடுவுல ஒரு 75th paper add பண்ணா எல்லா நம்பரும் சேஞ்ச் பண்ணிட்டு இருக்கணும் if you are doing in manual. But here you no need to do. If you are adding one more paper here means automatically it will change. I am adding this paper here. So automatically the number change as 2. This one is 1 irundhudu. First இது 1 irundhudu. இது 2 ஆ இருந்தது. இப்போ நான் இந்த பேப்பர் ஆட் பண்ணனே automatically 1 2 3 னு ஆட்டோமேட்டிக்கா மாறிடும் இதுவே. ஓகேங்களா? Okay. And finally for example at the end automatically it will include that papers. ஓகே ஆட்டோமேட்டிக்கா அந்த எண்ட்ல வந்து பாத்தீங்கன்னாக்கா பேப்பர்ஸ் எல்லாத்தையுமே அதுவே இன்க்ளூட் பண்ணிக்கும் சரிங்களா as okay suppose you want to unlink the citations full remove பண்ணனும் அப்படினா you need to give unlink citation. And one more thing, if you want to add that IEEE, for example, if you are submitted in the IEEE, okay, then the paper is rejected. If you want to submit the same paper in one more elsewhere, then it became a tedious process. You need to change all the references on that style, elsewhere style. That is one of the tedious process. For example, at Anna University for research scholars, and the 120 paper add பண்ணி அந்த style கொண்டு வரதுக்குன்றது it is a tedious process. Okay. If you want to change that document preferences means you just click the document preference and go to here document preferences la போயிட்டு elsewhere order. For example, if now I am going to change that pattern to Harvard style. That means elsewhere style la மாத்தணும்னாக்கா just click that one and click OK. The entire system will get changed. Harvard system என்ன சொல்லுதுனாக்கா I think something error is there. இத மட்டும் எடுத்துக்கோங்க. Etal methodல it is changed. பாருங்க Etal methodல மாறிடும் and then at the end the total system is changed as like this. This one is Harvard format. That is elsewhere format. Elsewhere formatல எப்படி இருக்குனாக்கா ABC formatல இருக்கும். author வந்து A nameல இருந்தனா A and then B and then C அந்த formatல மாறும். Now all are medical papers. For example, I am going to add this Electronics Journal of Biotechnology. Means if you place the cursor there, automatically it will show the style. என்ன ஸ்டைல் இருக்குன்னு இங்கேயே காமிச்சிடும் சரிங்களா. So that you can add it. Now I am going to add that electronics letters. The electronics letters under that now add பண்ண just you keep that will be added in that style. In the style இங்க வந்து include ஆயிடும். After included that one, you select that one, okay. And then click OK. Document preference போயிடுங்க. நீங்க இன்க்ளூட் பண்ணது இங்க அந்த எலக்ட்ரானிக் ஸ்டைல் வந்து இங்க வந்திருக்கும். BC electronic letters இங்க வந்துச்சு பாருங்க. Electronic letters will be appear here. So click OK. Then in the paper it will automatically change that referencing. Okay. If you want to, if it is not changed, இங்க include பண்ணிருக்கீங்க change ஆகலனாக்கா at the end you refresh. Change ஆகலனாக்கா refresh கொடுத்தீங்கன்னா automatically it will change. Okay. And then if you want to unlink the citations, means you can give unlink citation. Okay, if you give a that citation will unlink. Okay. One more thing, if it is not appeared at the end. Okay, cursor இங்க வச்சுக்கோங்க. இந்த இடத்துல வச்சிட்டு எங்க வேணுமோ அந்த இடத்துல place that cursor and then give add biography. இங்க ஆட் பண்ணீங்கனாக்கா citation நம்ம unlink பண்ணிட்டோம். அதனால இங்க காமிக்கல. So insert biography கொடுத்தீங்கனாக்கா it will included at the end of the reference. நீங்களே இங்க டைப் பண்ணிக்கலாம். reference டைப் பண்ணிட்டு below that we unlinked the citation so that it will not included. If once again I include பண்ணி காமிக்கிறேன். Here I am going to include one paper and go to include paper, go to add citation, include the paper, enter. The paper is included here. Place the cursor below the reference. Add biography, bibliography. Then it will automatically. Now it is in the electronic letter style. Electronic letter style so that like that you can include even hundreds of papers also. If you are having any doubts in this software or EndNote, you can nearly கிட்டத்தட்ட பாத்தீங்கன்னா ஒரு ஜர்னல் பாத்தீங்கன்னாக்கா 25 to 30 பேப்பர்ஸ் ஒரு ஜர்னல்ல ரிஜெக்ட் ஆச்சுன்னா அடுத்த ஜர்னல்ல submitting it to the another journal, it will take a tedious one. Okay, and also it will be very much useful for your thesis. You can simply do it by within 3 or 4 hours we can do it. If you are having doubt in EndNote or Mendeley, you can contact me. Okay, that's all. Thank you very much. I thank everyone for giving opportunity to deliver my presentation.
Good afternoon, respected dignitaries, Reverend Principal Sir, esteemed faculty members, and dear participants. On behalf of our institution, it gives me immense joy and enthusiasm to welcome you all to the valedictory ceremony. On our topic of global warming prevalence for climate-friendly energy production. To begin this auspicious occasion with an invocation, I request all to raise for the prayer song.
Jai
முந்திய நாளினில் அறிவுமில்லாது வைத்தனன் மனிதராம் புதுப்புனல் மீது செந்தாமரை காடு முத்தது போல செழிக்கையும் தமிழே கொடியே வாழி செழிக்கையும் தமிழே கொடியே வாழி செழிக்கையும் தமிழே கொடியே வாழி. Thank you. Please be seated. Over the past 6 days of our FTP, we have witnessed enriched sessions, insightful discussions, and knowledge-sharing experiences that have truly added value to our academic and professional journey. Now I request Dr. Meghnadhan Sir, Associate Professor in EEE, Coordinator of this FTP, to present the overview of this journey as a report.
Good evening to all. It my esteemed college, distinguished guests, and my dear participants, it is a great honor to present the validity report. The Department of Electrical and Electronics Engineering, Sri Venkateswara College of Engineering and Technology, successfully organized the 6-day faculty development program on global warming prevalence for climate-friendly energy production, held from 8th September 2025 to 13th September 2025. The program aimed to enhance the knowledge, teaching methodology, and research capabilities of the faculty members in engineering. The objective of the FTP is to provide in-depth knowledge on the recent trends and advance in renewable energy, to enhance the pathology skill and research aptitude among the faculty, to bridge the gap between industry practice and academic delivery, to create a collaborative platform for the faculty to exchange the ideas and best practice. The FTP commenced with an inaugural function on September 8, 2025 at 9 a.m. The session begins with the welcome address by Mr. Louis Kishore, Co-Coordinator, Assistant Professor of EEE, and Dr. S. Pradeep Jayanayan, Principal of SVCT, deliver the presidential address. Also, the chief guest for the session of Mr. V. Shanmugam, Founder and CEO of Tech Solar Technology, delivered an insightful keynote address by highlighting the importance of the continuous faculty development in a dynamic field of engineering and education. This session has been duration of the 6 days from Monday to Saturday. Out of these, 25 hours of teaching in 10 equal sessions and 5 hours for the practical sessions and 4 hours for the article discussion and 4 hours for the industrial visit and 3 hours for the MCQC and article summary and feedback session. In this day one, session 1 is handled by Mr. V. Shanmuganathan, Founder and CEO, Tech Solar Technology, Puducherry, under the title of Techniques of Energy Storage. In day 1, session 2 is handled by Mr. Satish Kumar, CEO, Sky Energy, Chennai, in the topic of digital electronics in renewable energy. In day 2, session 3 is handled by Dr. Pugarendran, Professor, EEE Department, IFET College of Engineering, Villupuram, under the topic of utilization biomass and its use. Day 2, session 4 is handled by Dr. P. Ajay D. Vimal Raj, Associate Professor, EEE, Puducherry Technical University, Puducherry, under its solar and its power device. Day 3, session 5 is handled by Dr. B. Magesh Kumar, Professor, EEE Department, Puducherry Technical University, Puducherry, under the title of Overview of Sustainable Energy. Day 3, session 6 is engaged by Mr. Leo Bernal, Senior Manager, Corporate EHS, Ashok Leyland, Chennai. His topic is Renewable Energy with Intelligent Management. And day 4, session 7 is taken by Dr. N. P. Subramaniam, Associate Professor, EEE Department, Puducherry Technical University, Puducherry, under the title of Emphasizing on Environment Sustainability. Day 4, session 8 is handled by Dr. G. Renuka Devi, Associate Professor, EEE Department, Jawaharlal Nehru University, New Delhi, where his topic is in sustainable development with the robotic sensor. Day 5, session 9 is taken by Dr. B. Edilavan, Founder and CEO, Well Technologies Private Limited, Chennai, under the title of Energy Safety via Climatic Adaptability.
Day 6, Session 10 is handled by Dr. P. Nammalwar, Associate Professor and Head EEE, Congaian Institute of Technology, E-Road. His topic is Utilization of Power Electronics in Renewable Energy. In total, more than 10 of the faculties applied with 8/10 of faculties applied between the 55 participants have approved and attend the session from various college. Out of these 15, which have includes the 65% of other states participants and remaining from the nearby engineering college. These sessions were interactive and well received by all the attendees. The 6-day FTP provide a valuable platform for faculty to update their knowledge and refine their teaching and research skill. The Department of EEE express sincere gratitude to all the resource person, management, organizing committee, and the participant for making this a grand success. Thank you.
Thank you so much for your detailed report. Now I kindly invite our respected principal, Dr. Pradeep Devnayan sir, to deliver the presidential address.
A warm good afternoon to everyone who are present here. My dear respected team of the EEE department and the faculty members from various institutions, my student friends, it is indeed a great pleasure for me to be here at the valedictory of the 6 days FTP, which has been organized under the funding of AICTE Atal. So it is a great moment for us to host this kind of FTP in our campus cause. It is not only funded, but the one thing which is very prevalent is we are addressing the actual thing that what the globe is experiencing now, the global warming. On the day of inauguration, I have spoken about the cloud burst, which we have heard about the last 15 days of time when the Chennai have experienced the cloud burst. That is the first time I heard so, I think so. In my whole life. Maybe 10 years back or 20 years back, we would have heard about it in some hilly regions in North India and some South India also. But nowadays, these are all happening in normal tropical region. That too, 2 days before, a place near to our campus called as Madhakatipet, which have also experienced a cloud burst. So this shows the great impact of us being engineers, we have to align towards the perspective of global warming. There are a lot of other things that we can do in our campus because many of you people are academicians where either we can be the torch bearers for our students so that we have to create some awareness to our students, not only in a point of just a consumer thing. It is not so that it is very easy to control the global warming. Okay, we can take a lot of measures in our personal life also. We have to be in a point, we have to be at the front foot to reduce the global warming in many other ways. How we can do it? Either we can go for installing the solar panels in our home. We can go for alternative way of transportation, not by the fuels or other things. We can go for electric vehicle, and we can even plan to go for any fuel cells and other things also. That way, personally, we have to impact this globe. Cause every academician, I always believe that we are the torch bearers of the younger generation, and we are the one who are going to show the way how to live in this real world. That way we can create a great impact in the younger generations. And apart from that, there are a lot of other spaces also. Since we are into the part of research and development, we have to really involve ourselves to develop some systems which will really help this globe to cut off from the global warming. See, nowadays we are in the month of September, right? Okay. A decade before or 2 decades before, the people who are in the age of 80, from the 80s and other things, we would have experienced a very chill climate during this season, right? But only today we are seeing a very chill climate for the past 6 days. the rest of the other 5 days were very hot. Am I right? So where we have to think about it. So there are a lot of things that we people have to work on it. We have to really develop many research projects which will be really useful for the future generations. So once maybe the WHO says that the age limit for each and every individual has been restricted to 70, right? Okay, if we live for 80, it is a God's gift actually. So we'll be here in this world for the rest of the 30 years or 40 years or 50 years of time. But after that, even there are people who are going to live in this world. The future generation are going to experience their life here in this world. So we have to leave back a good world to the people. So I always expect and I always request you all to concentrate on developing systems which will really reduce the global warming, which will really improve the climatic condition of this world, and that way we can have a sustainable lifestyle. It is not only about the renewable energy, it is also about the sustainable energy also. There are a lot of scope there, and many of our researchers are not getting involved in these areas. I request you all kindly to motivate your younger generation, either it is your undergrad students or a postgrad student or even your research scholars, to get involved in these areas to develop systems that will surely help this humankind. So that way, I think so that these 6 days would be a great days of learning for you all, and I hope so that you will take a lot takeaway from this campus, and I hope so that we would have gave a great a place to enjoy and to have a learning here. At this point of time, I want to congratulate the whole entire team of the Electrical and Electronics Department, right from this HOD, the coordinator Dr. Meghanathan and the co-coordinator Kishore, and all the rest of the other faculty who have contributed themselves, and most importantly the English department who have been here for the all day of 6 days for the comparing, and even the student volunteers who have involved themselves to make this event a very grand success. I once again wish you all a very bright future, and I hope so that in near future we'll be conducting lot of these kind of activities, FDPs, workshops and events in our campus. And I welcome you all for the future endeavors also. Thank you.
Thank you, sir, for your informative thoughts. No program is complete without hearing the voices of our participants. I request all the participants to share their reflection and feedback about the faculty development program.
Good morning, everyone. Myself, Amal Peter, and I'm from EEE final year. First of all, I would like to thank our institution for arranging this program. And for me personally, these 6 days have been For me personally, this 6 days I learned a lot, starting from climate change, how it is caused, and what are the effects on the environment, and statistics and history behind it, and also how to tackle those problems, and also learned about the battery storage systems, that industry standard insights, and also about the solar panels, and especially today's session done by Mr. Namal sir. I learned a lot about APPTs, and also how I learned a new thing about partial shading, how to overcome those problems using bypassing diodes. So I also got many insights for my projects also. So thank you.
Good afternoon, everybody. I am Dr. T. Rampradesh from IFPT College of Engineering, Vilupuram. So first of all, I'd like to thank the management and the principal of SPCET for supporting the faculty members for organizing such sponsored programs in the institution. I congratulate my friend as well as the coordinator, Dr. Mevanathan and Louis sir, for accepting me in this FTP. And I congratulate the organizing team of electrical electronics engineering. So all the resource persons were very well qualified, and they have delivered very nice sessions, which would be a very good help for the faculty members to carry out their research work. And specifically, the industrial visit of yesterday was very, very useful. So where we learned about the operation of battery completely from scratch to final product. So that was very, very interesting. And we look forward for more events from the institution in future. Thank you.
Good afternoon, and all. Myself, Sarvana Kumar, Associate Professor Tripoli from IIM Engineering College. Before this, after this corona, we have an online FTP. Most probably that FTP always in online, so we have missed this offline FTP. But first time after long gap, I'm attending this. Really very useful. And on the whole, I want to mention one thing. From entering the gate up to this time, up to this fourth floor, all the people receiving our service, it is very excellent. The hospital is very good, sir. Thank you for your good hospitality. And also, I would like to thank our coordinator, Mevanathan sir, for excellent arrangements for this program. Because while receiving the application and follow-up, everything was very good. And by they are motivating us to do everything, because we have many work, NAP work, NBA work, always we are engaged in many work. But in spite of this, follow-up is very good, and I would really like to thank Meghna sir and co-coordinator also. And I want to thank our SVCT management as well as the principal sir for providing this opportunity and accepting us for this FTP participant. Thank you very much, sir.
First of all, good evening to everyone here. I'm here to express my gratitude to our faculty members and our college, because the session was so good and gave us many insight about the future as well as the modern. And they have told and explained about all the insights and all the future technologies so briefly and so excellently, so that we can also easily learn it. And the sessions are so good because and some of them was slightly after lunch. We have some issues, right? After that, we have some sleep sessions also, but it was also useful, and we also tried to interact and try to focus on it, because it was so useful and useful, and it was so it provided us no acknowledgement, and we have 4 providing sessions in it, and we have a broad view about the future, and it helps us in the career also. Thank you, sir. Thank you for giving me the opportunity, and also thankful for college. Thank you.
So good evening, everyone. First of all, thank you for giving me this opportunity. This 6 days offline event was so inspiring and grateful. The way the chief guest given the presentation was so understandable, and we also gained the knowledge on impacts of global warming, energy production through renewable, and the importance of EV vehicles and manufacturing of batteries. And we also went to interstate visit where we gained knowledge practically, and we also gained knowledge on how the battery was manufactured. So overall session was so nice, and we also gained knowledge and use it in future. Thank you, Principal Sir, for organizing this event. Thank you. Thank you, Meghna sir also.
Is there anybody to share their feedback? So I thank all the participants for your valuable feedback. As we come towards the close of this program, I now invite Dr. Meghnadhan sir to deliver the vote of thanks.
Myself here for the vote of thanks for the faculty development program. It is my honor and privilege to deliver the vote of thanks at the conclusion of this enriching 6-day faculty development program on global warming prevalence for climatic friendly and energy production, organized by the Department of EEE, Sri Venkateswara College of Engineering and Technology, Ariyur, Puducherry. I am sincerely thankful to our Principal Dr. S. Pradeep Dayanand for a constant support, encouragement and guidance throughout planning and execution of this FTP. Your leadership has been instrumental in making this event a great success. A special thanks to our eminent resource persons and speakers who have generally shared their knowledge, expert and insight with us our past 6 days. Your sections were not only an informative but also throughout a provoking and have certainly broadened our academic and professional perspectives. To all the participants, I thank you for your active engagement, courageous and enthusiasm, your involvement. Through questions, through discussion, through the feedback, made the session even more meaningful and dynamic. I would also like to acknowledge the efforts of the organizing committee, coordinators, technical support teams, and student volunteers who have been involved in the session work to ensure the smooth conduct of this FTP. Your commitment and the team work deserves a special appreciation. A big thanks to all the support staff for taking care of logistics and refreshment and other arrangements that often get unnoticed but are vital to any successful program. Finally, I thank the management of Sri Venkateswara College of Engineering and Technology for providing us the platform and resource to conduct such an academic events. Let us carry forward this insight and idea shared during this FTP to our teaching, research and professional practice. With this note, I once again thank each and every one of you for making this program a memorable and meaningful one. Thank you and wishing all success. I am blessed because you are my blessing.
Thank you, sir. Let us all rise for the national anthem.
Jana Mana Adhinayaka Jaya He Bharata Bhagya Vidhata Punjab Sindh Gujarat Maratha Dravida Uttara Banga Vindhya Himachal Yamuna Ganga Uchchala Jaladhi Taranga Tava Shubha Name Jage Tava Shubha Ashish Mage Gahe Tava Jaya Gana Jana Gana Mangala Nayaka Jaya He Bharata Bhagya Vidhata Jaya He Jaya He Jaya He Jaya 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 He.
Please be seated. I request all the registered participants to join for the group photo session.